Okay, today I'm going to show you how to mark up the periodic table with valence electrons and the charges. So these are the group numbers up here. These are transition metals. The rules that the rules and the tricks I'm going to teach you today are not going to apply to the transition metals. So on our periodic table, we change this to 1, to 2, change this to 3, 4, 5, 6, 7, and 8. These numbers here tell us the number of valence electrons. So everything in group 1 has 1 valence electron, here's sodium. Everything in group 2 has 2 valence electrons, like magnesium. Everything in group 3 has 3 valence electrons, like aluminum, and so on. So the group number tells you how many valence electron that atom has. We're now going to use this to figure out what's the charge on the atom, because when these atoms go through chemical reactions, they bond, they come together, and the way that they come together is because of these electrons on the valence, the outside. So sodium has 11 atomic number, so it has 11 protons. It has 11 protons, it also has 11 electrons on the outside. On the valence, it has 1, because it's in group 1. So what it wants is that all of these elements want to have 8 in the valence. That's what makes them stable. That's why it's called the octet rule. They want 8. So what sodium is going to do, instead of figuring out how to find 7 more, is going to donate that to a chemical reaction. It's going to donate something negative, so it's going to have 10 electrons left over. It has 1 more proton, so its charge is positive 1. So now we're going to add charges to our table. So everything in group 1 has 1 valence because it's in group 1. Whenever it does a chemical reaction, it's going to donate that 1. The thing it's donating is negative, so it's going to be more positive by that many 1. In group 2, they have 2 valence. We have magnesium. There's 12 protons on the inside. Therefore, there are 12 electrons on the outside. There's 2 on the valence because it's in group 2. It wants to have 8. So what it's going to do, it's going to be easier to get rid of these 2 during a reaction instead of stealing 6 from somewhere else. So now it's going to have 10 electrons and 12 protons. So it's going to have a positive 2 charge. It's getting rid of something negative. The thing it's getting rid of is negative. So it's going to have a positive charge of 2. In group 3, like aluminum, there's 3 on its valence. When it does a chemical reaction, it's going to donate these 3. It's donating 3 things negative, so it's going to have 10 electrons. You can see there's 10 electrons and 13 protons. It got rid of 3 things negative, so it's going to have a charge of positive 3. In group 4, it could either accept or donate, so it'll have a charge of plus or minus 4. In group 5, like phosphorus, it has 5 valence. It's going to be easier now for this substance or this element in this table to steal 3 from someone else. So it's going to steal 1, 2, and 3 during a chemical reaction. So it's going to have 18 electrons or a negative 3 charge because it has 3 more negatives. In group 6, like sulfur, there's 6 valence because it's in group 6. 1, 2, 3, 4, 5, 6. During a chemical reaction, sulfur is going to steal 2. It's stealing 2 things that are negative. So it's going to have a charge of negative 2. In group 7, there are 7 electrons in the valence. So what it's going to do is it's going to steal 1, giving it 18 electrons. Has 1 more electron. Sorry, that's 1. So it has a negative 1 charge. Elements in group 8 already have their octet full because they want 8. They're in group 8. They have 8. So they're going to have no charge. These are called noble gases. And they're called nobles because they're unreactive. They already have their octet full, they're happy. I hope that helps.